This is Unit 4B review. I've put a couple things together and I've got some examples to show you to hopefully kind of help you a little bit with this. Okay, so let's go ahead and go over to this chart. So I made you this chart, and the main things on 4B are the three types of probabilities is random variable, binomial, and geometric. So let's go one at a time here. Random variable, you're going to see that when you have some sort of a chart that looks like this. You have an x and you have the probability of each x. Remember that when you add all of these up, the sum is going to be 1. The formula, which is on your formula chart, is going to be each of these plus each of these. You multiply each of the things that I highlighted in pink times each of these. So this would be 1 times 0.1 plus 2 times 0.5 plus 3 and so forth and so on. On the test, you would write the mean is equal to 1 times 0.1 plus ... And you'd be multiplying all them, 1 times 0.1, 2 times 0.5, 3 times 0.2, and so forth and so on, all the way to 5 times 0.15 to show that you're doing that, and then you'd put equals the answer. Now, the way you do it on your calculator is from a spreadsheet. You do menu 4, 1, 1, okay, 1 list, and you'll have a drop-down menu with the X and a drop-down menu with the frequency list. And this X list is going to be your X list, and the PX list is going to be the frequency list. Let me go ahead and do that for you. So I'm going to bring up my CAS here. And you're going to bring up a spreadsheet. Okay, and you're going to label it. So I'm just going to label mine X, and I don't ever do it as a single X because it's going to confuse it with your, oh, hold on, it's giving trouble with this. There we go. Syntax error. Okay, come on, let's go. Let's try to get this. I'm just going to do a normal one. So we're going to call this list X. If I do anything else, it will mess it up. So let's go again. I went 1, 2, 3, 4, 5, I believe is what I had. And then if I remember the probabilities right, I'm going to just write PX on here. X, and that's the probability. 0.2, I think I had, 0.5. I don't remember what exactly I had, but I believe this was right, 0.1. And then I think I had 0.05 and 0.15, I believe. All right. And so to do that, of course, I can multiply in the way I showed you. But if we're going to go to menu 4, which is statistics, 1 stat calc, 1 variable, we're going to hit OK, 1 list, OK. And this is going to be a drop-down menu of what I called list, what I call my A. And so this is list. And then the next one's my frequency list, which was PXX. 1. And then I hit OK. And you can see my mean is 245, and my standard deviation is right here at 1.28, right there, 1.28345. So I had 2.45 here, so this is just going to be 2.45. But notice all I did was I multiplied each X by each of its probability. And the standard deviation, what you're going to do there is you're going to do this. You're going to, let's look here. I'm going to keep going on a little bit. So it's each of my X's. So 1 is my first X here, minus my mean, which I have back here, 2.45 squared times the probability of that X, which is 0.1. I'm going to keep having it go plus ... plus, and I'm going to go into, and so I'd have to do it with 2, 3, 4, and 5. Then I'm going to do the last one. On the test, I'm just going to do 2 of them and ... 2.45 squared times 0.15, and that is equal to, remember why I had it over here, 1.284. 1.284. Make sure you label what it is. I didn't tell you what the X variable represents, so make sure, I'm just going to put units because I didn't tell you what it is, so we'll just put units. Okay, so that's a random variable. So let's look at the center of the random variable. So the center, when I add, let's say if right here is my random variable, and let's say I add 5 to everything. I'm going to add 5, add 5, add 5, add 5, add 5. Okay, remember my original variable, so I'm going to just go ahead and say add 5. My original variable, original mean was 2.45. Now my new mean is going to be 2.45 plus 5, so 7.45. All right, my spread, my range, my IQR, and standard deviation does not change, so there's no change here. So this would still be my 1.284. My shape is not going to have any change either. I didn't graph this to see what this shape is, but whatever it is, it's not going to change because all what's happened is I have shifted it down the number line by 5 units. It's just moved down to the number line. Okay, let's try to do something else to it. Let's just multiply it by 2 now. Multiply by 2. Multiply everything by 2. Now, I'm ignoring the plus 5. I'm not adding 5 and then multiplying by 2. I'm just doing the original by 2. So if I did the original by 2, I have 2.45 times 2. So that's going to be 4.9. So I'm just multiplying by 2. We're multiplying by 2. So whatever my constant is. For the spread, I'm going to take that 1.284, and I'm going to do 1.284 times 2, and I'm going to get 2.568. For the shape, there's no change. It's just going to be spread out more, but the shape, like if you throw a blanket over it and you look for what it looks like, it's just not going to be any change. All right. I also want you to see the standard deviation squared is called the variance. Okay, so make sure that, and spread, which I should have added variance here too, actually, is also part of the spread. We just don't typically talk about it in that sense. Usually it's range, IQR, or standard deviation. But remember, standard deviation squared is the variance. That's important because with the mean, if I have, this is, x, if I have the mean of x and mean of y, and we're adding them together, let's say that I have the mean of x here and the mean of, let's say I give you the mean of y. Let's go, okay, I have another set of data. Let's say the mean of y is equal to 1.3. Standard deviation of y is equal to, let's say, 0.2. Okay, so if I ask you to add the mean of x plus y, then I go 2.45. Plus 1.3. So it's going to be 3.75. The mean of x minus the mean of y is just 2.45 minus 1.3. It's going to be 1.15. So standard deviation, let me just move this around so I can we're going to do the standard deviation of x plus y. Standard deviation is just going to be, notice I'm squaring the variances and adding them. And so the standard deviation was this one, 1.284 squared, plus this one is 0.2 squared, because that's my y, and then square root. So that would be 1.284 squared plus 0.2 squared. And that's going to be, and then the square root is going to be 1.29. Now, if you notice, this formula here is the same as this formula here, even though this is adding and this subtracting, because I showed you in class adding 2 data sets together, what happens is, yes, it spreads out when you add 2 data sets together, but it just shifts if I subtract the same 2 data sets, but it's going to be the same, 1.29. So this here is going to be the same as this, because you notice this is exactly the same to get it that way. Okay, so that's for random variables. Random variables don't have anything special about them. There's nothing special. There's no, no special conditions or anything. So you have to go through all of this. Now, if you did the other ones, which we're going to be doing binomial geometric, and if you found the mean and standard deviation, this using a random variable, this is called a binomial random variable. This is called a geometric random variable. So they're random variables, and so these formulas work for binomial and geometric. But there's some special formulas that only work by binomial and only work for geometric as well that make it a little bit easier to do. All right, so let's look at those. If I have a binomial, you'll see this is my formula. Again, this is on my formula chart. And remember, this one was the pop quiz one, where I had 5 questions. And I had A, B, C, or D on all of them, A, B, C, or D. And I made you in class randomly choose any of these. And you said, okay, A, maybe C, B, D, whatever. And I just had you guess completely. It wasn't an actual real quiz. And then I graded it to see how much you would get right if you just were guessing. All right. So if you look at the mean on the formula chart, it says NP. N is the number of trials. And P is the probability of success. So here you have N is the number of trials that I just said. K is the number of successes. So successful trials. All right, so this here is the number of ways things occur. So I've shown you guys this before, but I'll show you the formula again is N factorial over K factorial, and then N minus K factorial. So if I had 5 people and I want to know how many ways I can choose 2 of them, this is what it would be. 5, choose 2. You put the 5 and the 2, and then 5 minus 2 is 3. This would be 5, 4, 3, 2, 1, 2, 1, 3, 2, 1. Cancel out, and this would be 5 times 4 is 20, divided by 2 is going to be 10. There's 10 different ways, so that would be this portion. On your calculator, if you look at it, let's go back to the calculator just to review. Let's go to a calculator page. If I went to menu, probability, combinations, and I said 5, 2, there's my 10. So that's the way I would do it on the calculator. So you don't have to show it out and do the work the way I'm doing this work right here. You can just literally do it on the calculator, right? And so that's NCR on the calculator, 5, 2. And that's also 10. But you see, that's the first part of the binomial formula. It tells you how many ways that we're about to do what we're about to do. The second part of the formula is the probability of success, and K is the number of successes. Then the last part of the formula is the probability of failure and the number of failures. So if I do one really quick and I say, okay, with the pop quiz, what's the probability, as we said, of getting 2 correct? And so we'll have 5 choose 2. And the probability of getting 1 correct, ABC, is going to be 1/4, right? 1 out of 4. And I got 2 correct. And the probability of getting incorrect is 3/4, and that means I would get 3 incorrect. I could put this into my calculator just like this, and I could go ahead and solve it. Or I could use a binomial calculator, which I'll use here, which is menu, statistics, distributions, and let's go to my binomial PDF calculator. And it says number of trials, 5 trials. Probability of success was 1/4. And I want to know the probability of getting 2. And there we go, 0.263, which would be 0.263. If I want to know the probability, I'll do one more over here, of, let's say, this was the probability of x equals 2. Let's do the probability that x is less than or equal to 4. So this is going to be 5 choose 0, because I could have 0 all the way up to 4. 1/4 to the 0, 3/4, because the number to the 5th. So this is the probability of getting 0 right, and then I would do 1, 2, 3, and then finally 4. So 5 choose 4 would be getting the probability of getting 4 right, 1/4 to the 4, and 3/4 to the 1. So I'm going to now, instead of doing all these out, because this would be a lot to do on a binomial PDF calculator, so I'm going to do a binomial CDF. Menu, stats, distributions, go down to binomial CDF. Number of trials, I have 5 trials. That means I have 5 questions on my test. I have a 1/4 probability to get one right as far as guessing. Lower bound, I said less than or equal to 4, so it's going to go from 0 to 4. And I have a 99.99, a lot, right? You have a really high chance in getting at least one of those correct from 0, 1, 2, 3, or 4. Looking over here, which I'm on my standard deviation section, this is the standard deviation section. My standard deviation is square root of NP and then 1 minus P. And these are both on your formula. All three of these are in your formula chart. Every single one of them, if you look under binomials, are in your formula chart. Okay, this is not on your formula chart. You have to memorize this, and this is SPIT. SPIT is the conditions. What must it be before it is binomial? Success, failure. Meaning I have two choices. For this one, I had correct or incorrect for my quiz. P means the probability must be the same for each trial. So we had the probability was 1/4 for each question. This is independent trials. Each one must be independent. Each question must be independent. And finally, the trial is a set number. And so N for this was equal to 5 because I have pop quizzes, I had 5. And if all four of these conditions are met, then I can say, therefore, this is a binomial random variable. Okay, let's look at the shape of a binomial random variable. We have three choices. If the probability is less than 50%, then if I have this is, let's say 50%, this is 100%, right? Most of my data is going to be over here. And occasionally, I'm going to have something over there. So the shape is going to be skewed right. Let me just kind of make it more clear. And most of my data is going to be over here. And you're going to see the graph pulled to the right. And that's where it's leaning to the right or skewed to the right. Okay, if my probability is greater than 50%, then I'm going to say most of the time I'm saying the probability of it happening is mainly over here near 100%. But occasionally it might be less. And that would be skewed left. Obviously, if the probability equals 50%, it's going to smack dab in the middle. But these have an exception to the rule. Here's my exception, that it doesn't matter what the probability is if my successes and failures are both greater than or equal to 10. So I have 100. If n is equal to 100 and p is equal to 10%, that's equal to 10. And 100 times 90% is equal to 90. Both of those are greater than or equal to 10. In that case, it's going to look like a normal model. It's going to be approximately normal. And now you are able to use the normal model with the mean equal NP and the standard deviation equaling square root of NP 1 minus P. And then you can use the normal model in order to solve your problems. All right, let's look at the final one of geometric random variable. So the geometric random variable was the game that we played called Greedy Pig. On that game, everyone stood up and I rolled the dice and you had the number and your points was the number that was on the dice, and every time I rolled the dice, you got more points. So if I rolled a 4 and then I rolled a 5, everyone standing has 9 points, and then I rolled a 3, everyone standing has 12 points. But then if I rolled a 1 at any time, everyone lost their points if they were still standing. At any point of any of my rolls, though, they were allowed to sit down and freeze their score. But any time I roll until I roll a 1, and that was my stopping rule. And that was what we called my success. And I understand that you're like, wait a minute, you lost all your points. That's not a success. You can define success as anything you want. Basically, it's until my stopping rule is my defining number. All right, the formula for my geometric is basically fail, 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 success. So it's fail, 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 success. There's always one success, and there's always one or the total number of trials minus 1 fails. Now, conversely with binomial, I can have 0 successes, so I could get all of them wrong, right? I could get them all wrong. Or I could get them all right. With geometric, I have to have one success and the rest are fail. So I have to have only one success. That's it. It would be one success. It would look like this for my test. X, X, and then one success, stop. X, X, this is a new test here. X, 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 success, stop. If I got the first one right away, then I stop. So as soon as you get a success, you stop. That's geometric. So my mean is just 1 over the probability. My standard deviation is square root of 1 minus p over p. And the conditions for this I call PIS. And if you notice, this here, though, SPI and PIS are just reorganized in a different form. And this here is success failure, independent, probability the same, right? So on my case, this one is 1/6 for what I'm doing. Independent success failure was 1 or not 1. But you see, these three are the same conditions. These three conditions and these three, the conditions are identical. The distinguishing factor is this last one. And this is stop at your first success. Where with binomial, the trial is a set number. This one is fail, 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 success, stop. This one is you're doing 5. It could be look like this. It doesn't matter. I'm doing 5 regardless. All right. The shape for this, because of this, let's say for the greedy pig we have a 6. Most of mine are going to be around 6, right? You're not going to have very many to the left because there's not many more numbers to the left, but you could roll and roll and roll and roll. I could literally, and we'd have seen in class, when I rolled the dice 25, 30 times and I still didn't get a 1. And so it looks like this. So this is always skewed to the right, where binomial was not always skewed to the right. So let me just kind of zoom out and let's look at everything all at once. And this is kind of what we're going to be tested on. So I have a few examples I'll go over with you. I just kind of circled some that seem like they might be helpful. Oh. And these are available on College Board. You can see the answers are already on College Board. And I have the PDF available on Canvas, but then you have it interactive on College Board, so you'll get the answers. So let's look at number 4. A certain bakery at the price of donuts of $1.50. Let the random variable D represent the number of donuts typical customers each day. The expected value and variance of the probability are 2.6 and 3.6 donuts squared. Notice it says donuts squared because the variance says is 3.6. Donuts squared. You know why it says donuts squared? Because the standard deviation is the square root of this. So it's going to be the square root of 3.6 donuts squared. So it's going to be donuts. Okay. So it says, let the random variable P represent the price of donuts. Now it's $1.50 per donut. Which of the following is the standard deviation, the probability? So I'm going to take 1.5 times the standard deviation. Now, the standard deviation, as I know, is going to be the square root of 3.6. So this is just going to be 1.5 times square root of 3.6. Because remember, back here, when we were doing ours here, you can see what I'm going to do is, what I'm going to do is standard deviation. When I multiply, is I multiply. Remember, when I multiply all my data, then I multiply the standard deviation. Okay, let's look at this one here. This following table shows a probability distribution for books. And it asks for expected value. Expected value is this one times this one, plus this one times this one, plus this one times this one, and so forth and so on, all of them. And you can see it right here. I have the work down here, which on your calculator is menu 411. Once it's in a spreadsheet, okay, and then the drop-down menu for the X, the drop-down menu for the frequency list. You have to do both, otherwise you will get it wrong. Because if you average these, guess what you're going to get? You're going to get 3.5. And they have that answer there, but it's wrong. Because this is a weighted answer. This is 35% of the time for this. They're not equal percentage of time. So make sure that you don't forget that you either do it by hand or you put in your calculator menu 411. Don't forget the drop-down menu, otherwise you will get the wrong answer. All right, let me scroll down to this one. I marked this one. Okay, this one is asking for the best interpretation of the mean. I've seen a bunch of interpretations of mean and interpretation of standard deviation, and all of them always have a long run average. And so when you look at this says each member visits 3 or 4 days per week. It says the mean is We don't know that, and that's not quite true. Some could be 0, some could be 10. We don't know that. So this is ambiguous. We don't know that. The average number of days that each member visits is 3.1. This is. It's very deterministic. We're not saying it's 3.12 each week. We are saying that's the average that it is, and so it's going to be approximately that. Half the members visit 3 days per week or less, and the other half of 4 days or more. No, we don't know that. Again, we don't know what it is because we just know that the average is 3.1. Here we go. The long run average from repeated sampling of members will approach 3.12 days per week. That one sounds nice and ambiguous, and it's saying this is just about what it is. Let's look why E is bad. For a random sample of members selected in the population, the average numbers of visits for the sample will be, that's the problem. Most of the time when you see the word will, again, it's too deterministic, and it's not exactly 3.12. It's just going to be around 3.12. Okay, here's another one I wanted to do. Okay, this one here is wanting your mean and standard deviation. So it gives you a mean of 10, standard deviation of 4. The other one is a mean of 7, standard deviation of 3. So the mean is going to be 10 minus 7, like it showed here. Oh, it shows the work here so nicely. I don't even have to do it. Look at that. And then the standard deviation of 4 and 3. And so as you notice, remember, even though it's subtracting, remember, like I showed you back here, these two formulas are the same, that you're going to add the variances and then find the square root. And that's exactly what I'm doing. I'm adding the variances and I get 25, and then I need to find the square root. Okay. Here's another one. According to the 2015 census data, 42.7% of Colorado residents were born in Colorado. If a sample of 250, okay, it gave me a sample. The fact that it gave me a sample lets me go ding, 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 ding. Let's try spit, because that may be binomial. So I'm going to kind of look around. I say, okay, trial set number. I already have that. I'm going to keep looking. If they're selected at random, what's the standard deviation of residents in the sample born in Colorado? And so I'm like, okay, each one born is going to be, it's going to be independent from the next. It tells me the data, 42.7% of the residents. So I'm going to say the probability is the same. And the success failure, Colorado, not Colorado. So I'm like, okay, this is binomial. That's really good news, because then what I'm going to be doing here is I'm looking for standard deviation, and the standard deviation formula is square root of NP1 minus P. So now I have the formula, and now I just have to plug this in, which is really simple, because I have 250, 42.427, 1 minus 0.427, and then I have the answer. Oh yeah, I've got it nicely down here too. All right, so that's the important thing of recognizing binomial. When it gives you a sample, that's what you want to recognize, so that then you can use your formulas nicely. All right, in 2014, 85% of households in the United States had a computer. For the random sample, oh, here again, 200, n equals 200. So I'm going to check if this is binomial. I'm going to spit. And I say success failure, computer, not computer. Probability is 85%. Each person's independent from the next, and trial is a set number. It's binomial, so that's great, because this specifically asks for mean and standard deviation. My mean is equal to NP, and my standard deviation is equal to the square root of NP1 minus P. And my work here shows it so nicely, so I'm just going to let it speak for itself. All right. According to a recent survey, 47% of the people living in a certain age group carry a genetic trait. People from the region will be selected at random, one at a time, until someone is found. When it says until someone's found, that sounds like fail, 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 success, stop. And so this looks like geometric, which is PIS. So I'm looking at it, okay, stop, we already got that one. 47%, P equals 0.47, so that's that one. They seem to be independent from the next, and then success failure, have the genetic trait and do not. So this one looks good. And the reason, again, that's important is because then I can have formulas. I know it's geometric. I'm recognizing this as geometric. And it says how many need to be selected to find one person who carries the gene. And so the mean is equal to 1 over p. So I do 1 over 0.47 because this is my formula. And that's it. Okay, for this one, it asks on average, how far will this vary from the mean? That's the definition of standard deviation. And standard deviation, well, let's see what we have. We have, oh, it tells me geometric. So that's going to be square root of 1 minus p over p. Oh, if we can, oh, we're stuck. There we go. Oh, right here. And we get 3.46. So that definitely is the definition of standard deviation. I think that's all I have for us. Yeah. Okay. Now these all, as you can see, are already located. It's your extra credit. If you do them, you know, I've done a lot of them with you in class or on here. And if you do them all, go ahead and make sure you show work or just make notations like I have kind of been doing. Some of them, there's definite work you can see on here, but some of them isn't as much work, but you can just make notations. And then that will count as your extra credit. And if you have any other questions, please let me know.